Okay, so this class is going to be about chapter 8. And chapter 8 is all about the geometry formulas. And so I would suggest that you start making a list of the formulas, unless you already know them by heart, and then you don't need it. But if you don't know them by heart, maybe make a page of just formulas. And so this is 8.1, and it's called perimeter and circumference. And these two are put together because they're both about the same thing. So let me bring this so that you can see it. So 8.1, perimeter and circumference. So many times when they ask you to do these, they actually show you the picture. So this is a square, it's a pretty good square. This is the rectangle. So typically a square is actually a rectangle. It's just all the sides are the same. Then there's something called a parallelogram. And I want you to see, it's like if you took this rectangle and tipped it over. In other words, if these were just attached at the corners and you just tipped it over, that's would be a parallelogram. Okay. This is a rectangle. And this, of course, is a square. And by definition, a square has all the sides exactly equal. And there's one more that they talk about, and it's basically the triangle. So the triangle, by definition, has 3 sides. These are all called polygons, and poly means many, and gons means sides, so many sides. So you could have a triangle, a square, or you could have even more advanced than this, but these are the ones we're going to deal with. So the whole idea of perimeter is basically, can you get the outside edge? Outside edge. So I think the picture tells you what to do. Now there's in the book or in the instruction ebook, they're talking about, they're putting in all kinds of formulas. But the truth is, if you can see it or draw it yourself, they say it's a square, you draw it, you can figure it out without any formula. So let's say this one is 5 inches and they tell you it's a square. Then you know for sure that every single one, every single side would have to be 5. And so if you want to get the perimeter, and they use P for perimeter, you can use the formula 4 times the 5, or just go 5 and 5 and 5 and 5. That would be 20. Do you see it's visually 5, 5, 5, 5, just march around the edge and grab it all up. If you had a rectangle, and they say it's a rectangle, and the thing about the square and the rectangle is the sides are perpendicular. In other words, 90 degrees. You know what I'm talking about, like the edge of the screen or the edge of a piece of paper. So what happens with a rectangle is, if you know one side, and it doesn't, let's do yards. So it's 8 yards, and then this one is 4 yards. And somebody said, oh my goodness, I want the perimeter. They typically would only give you these 2 measurements, the length 8 and the width is 4. They may draw you a picture, or they may just give you those 2 facts. But if you draw it, you can see what has to happen as far as the formula is concerned. If this side is 8, then the opposite side has to be identical. And if this side is 4, this has to be identical to the one opposite it. So that's what rectangles do. And so if you had to get the perimeter, you would need 2 of the 8s, right? An 8 on top, an 8 on bottom, 2 of the sides, a 4 and a 4. And so that's the formula. But do you need a formula to figure this out? No, you could march around the edge 8 and 4 and 8 and 4 if you want to, and you would get the proper answer. And these were all in yards, by the way. I just didn't want to label everything. So the formula is just a shortcut. 2 of the 8s and 2 of the 4s. Did somebody have something? So that would be what, 16, and this would be 8. That would be 24 yards. You see what I'm saying?
Yep.
So you can draw it. If they didn't draw you the picture, but they told you the length is 8, and this is the length, and this is the width, and the width is 4, if you draw it and label it properly, you've got it. Now, perimeter for a parallelogram, remember, this is this rectangle that got tipped. And so what happens, and I'm going to make this 7, but because these lengths did not change. So if this is 7, this would be 7. And if this was 5, this would be 5. So opposite sides are equal. So if they told you, this way is 7 and this way is 5, you've got the same crazy thing. I need 2 of the 7s to get perimeter and 2 of the 5s. So perimeter would be 2 of the 7s and 2 of the 5s. So the fact that it was tipped didn't change how much it needs to get around the edge. So that would be 14 and 10. In this case, it's 24, whatever the unit was. Is that okay?
Mm-hmm.
All right. And this one is the most obvious. With a triangle, there's no telling if any of the sides match. Whereas here, these 3, you have matching sides, remember? Opposite sides were the same, and in the square, they were all the same. But in a triangle, everyone could be different. If this was 3 and this was 4 and this was 6, they have to give you all 3 if they want perimeter, because you have no guarantee there's a match. So you would go 3 and 4 and 6, and that makes 13, whatever the unit was. Let's say it's meters. If they were all meters, then it would be 13 meters. Now, I've noticed in the when you do the problems, you don't have to enter the unit, yards or inches or meters or whatever. But with perimeter, it's always the plane unit, not the square unit, which we'll see in a minute when we do area. So it's always the plane unit, but they're providing it. They put it into the reading, so you don't have to enter it yourself. Now, I'm going to do this one. Circumference has to do with going around the edge of a circle. Now, these were so easy to, you measure that and you measure that and you can do it. But this is a little bit trickier. How do you measure a curved surface? Well, I'm going to draw it bigger. First of all, we need to know 2 things. One is the distance from the center to the edge is r, and r is the radius. Okay. The other thing you see a lot in these formulas or in these problems is what if they told you all the way across? So it's basically this. This is called D for diameter. Now, the interesting thing about this is, I don't know if you remember using a compass, so you'd mark it in here and then you draw the circle. So the radius has to be the same everywhere, or it's not a circle anymore. It's kind of misshapen. And so if you knew that the radius was 5, the distance from here to here is the same as the distance from here to here. I don't know if I got it quite centered. So can anybody tell me how much the diameter would have to be?
10.
It would have to be 10. So if they give you the diameter and you need the radius for a formula, you have to cut it in half. If they give you the radius and that you need the diameter, you have to double it. And I think it's easiest to see with a picture. Okay. So there's 2 formulas for circumference. And this is one of them. Now, you may have learned another one, and so I'll show you that in a minute. But I'm going to do this one first. And let me see if I can find something. This is a cord to charge my phone. I'm going to take this and I'm going to measure the diameter. You see what I did? The real question is, the reason I use the cord is so that I can wrap it. That would be 1 mark. This would be 2. This would be 3. So I wrapped it and it went that far with 1 diameter. It went that far with another diameter. Did you see what I did? This is a visual. That's the diameter. First time, second time, third time. It looked like it was 3. It wrapped around 3 times, but the truth of the matter, it was 3 with a little bit left over. When they finally figured this out, they originally thought it was just, it wraps 3 times and that's the end of it, but it's not 3. This is a rounded off number, rounded to 2 decimal places. This is pi. Pi is a Greek letter, and the Greeks had a lot to do with math. And so a lot of times you see a lot of Greek in math, and that's the reason. They would use their own language, their own alphabet. They didn't use English. They used Greek alphabet. And the Egyptians figured it out too. That was the other thing. But here's the formula: circumference. So this is the answer that they typically will tell you. Pi is used 3.14. The diameter in this problem was 10. So I picked these numbers because I can now just, when you multiply by 10, it's a decimal shift. And so it would be 1 place to the right. So it'd be 31.4. So the distance around that circle is approximately 31.4. And it just depends if this was in meters, this would be in meters, but they're not expecting you to fill that in. So if for some reason they gave you this picture and they said, They marked it as 3, and maybe they were nice enough to say that's the radius, maybe not. If you use that formula, this one that I just gave you, you would put 3.14 first. But what would go second?
9. No, 6.
6 it is. So I would suggest, because if you go all the way across, you've doubled it. And so it's 6. And so that's what has to happen. Then you just multiply this. And if you want to use a calculator, you can use it. But that's what you're going to do. 24, carry it 2, 8, 18. Okay,
That was quick without a calculator.
I just did it. Why did I do it so fast? Because I had to learn without a calculator. You can tell I'm not young. I had to learn without a calculator. I didn't have one until I was in college, a calculator.
I had one since day 1 of school.
Yeah, and I think you need to be able to do some of it so you recognize your mistakes. I typically, when I make a mistake, I feel it in my bones and I look again. Now, this particular thing, there is another version of this for circumference, but I think the other one is just perfectly fine. But if the radius was 3, you may have learned this 2 pi r. So I'm just mentioning it in case somebody knows it this way, and that's it. So it'd be 2 times 3.14 times the radius. So the formula itself doubles the radius. So the 2 times 3 is really the 6. And so it accomplishes the same thing we just did. But to me, this seemed a lot, but it doesn't matter which formula you use, but I typically stick with this one. Instead of having 2 versions of the same exact thing, I just typically stick with that. Is that okay?
Yes.
The same thing. Now, 6.2 is about area. Now, 6.2, it's 8.2 in chapter 8, right? So this is about area of these same figures that we just drew. And so I'm going to start with the rectangle, because I believe some people.
Professor,
Go ahead.
I'm requesting to take you back to the radius where there is a C and these other 2 things. Yeah, there.
Yeah.
Yeah, you repeat it for me.
So if you learned it this way, then the 2 times the radius is really 2 times 3 is 6. So it's basically taking into account that the diameter would be 6.
Okay.
But what I was suggesting is, if you never learned it, I think this probably is more straightforward. The radius is 3 and diameter is 6. And so all you have to do is 3.14 times 6.
Okay. Okay, thank you.
It's really up to you. They're both good. So here's area. Area is inside. So we're not talking about going around the edge perimeter. We're talking about covering it. So there's all kinds of problems. You cover the floor with a carpet. You cover a field with possibly grass seed or something. But that's what you do. And so what we're talking about is inside this shape. Now I'm gonna turn this into that. Somebody. Okay. All right, somebody went out.
Is there area for a circle? Or
There
is
is
that just
a formula for area of a circle. And I'll get there, but I want to do the straight ones first. This one here, if this side, this is a rectangle, was 3. And this side was 5. The question is, how many squares would I have?
5 times 3?
Exactly. 5 times, can you, 1, 2, 3, 4, 5, 6. 15. And the simple formula is area equals the length multiplied by the width. So let's say this was feet and this was feet. They need to be the same. So area is 5 feet multiplied by 3 feet. So this might actually be simpler as far as the computation is concerned. 3 by 5 is 15. And there's 15 squares. Now, the interesting cute part is the words feet and feet multiply as well. So feet times feet is actually square feet, and they are squares. If you look at them, we have 15 squares, don't we?
Yep.
15.
I
Again,
just think it's
the
funny.
square feet, they're not going to require you to do it. They're going to type it in, and all you have to do is apply, the number for your homework. But this is good to know. Area is always square feet, square inches, square yards, square meters, any of those. So to do area, you always get square something. And so that's just a good thing to know. So that's the rectangle. Now, if for some reason they said, okay, well, this is a square. Okay, I'm into visual. If this was 3 and this was 3, and they said, okay, we want the area here. How much?
9.
9. So the formula,
9 squared.
even, you could use this formula because a square is actually a rectangle. It's this number times that number. They show it as one side squared, but I don't think you need that. This one will do it for you. You already have it anyway. So that would be 3 times 3 would be 9. And it would be, let's say it's meters. Square meters. But again, you're only going to have to give them the number. So those two are really the same, aren't they?
Mm-hmm.
Uh-huh. Now, what happens if they kind of said, okay, now we're going to tip it. This is the parallelogram. So it's really just the rectangle tipped. Okay. This is a visual. You see that little corner, this little
Mhm.
triangle here?
Mm-hmm.
What if I picked it up and put it over here? I'm going to take this up and put it over there. What do I have?
A rectangle.
A rectangle. It's a visual rectangle. The truth of the matter is, instead of length and width, they're going to call this B for base. It's typically on the bottom, but it depends how if they turn it or something, but it's typically on the bottom. This vertical distance, which would have been the rectangle, is here in the dotted line, and it's H for height. But the name of these two really doesn't matter because it's the same darn thing where we're going to do. So the formula is the base times the height. But let's say the base was 9 inches and the height was 4 inches. What's your area?
36.
Exactly. 9 inches multiplied by 4 inches, 36 square inches area. Because if you move this over and put it over there, then this little piece would end up going there and you would have your full 9. And then the height has to be perpendicular. You see how this is? When you use the word height, it's implying that it's perpendicular to the base. And so the measurement of this slanted side has absolutely nothing to do with area. It's only the height, the vertical distance, the perpendicular distance is the one you need. So occasionally they throw in numbers that you don't need, and so you have to pay attention. So let's see. Let's say there were let's say they were playing games with you and they decided to tip it. Well, the truth of the matter is there it is, right? And so what would you multiply by? Area. This is actually the base.
10
And
times 5.
visualize, yeah, it's 10. And then what's the height?
5.
Area would be 50 square, whatever. Okay, so occasionally they turn them, they're playing games with you. Can you visualize it turned? Turn the paper.
Is it still going to be cubed at the end?
What?
Is it still going to be cubed at the end?
It's square. Area is always square. So
Okay.
if this was yards and this was yards, it would be 50 yards square.
Okay.
So area always square because there's, this was yards and this was yards and that's 2 of them.
Okay.
Now. The triangle. Now we're going to try to figure out what's inside the triangle. Well, that looks like more of a challenge compared to the rectangle and stuff. But I want you to visually see what I just did? If you include everything inside, not only the original triangle, but the part that I kind of dotted, what is the shape we're seeing?
A rectangle.
It's a rectangle. So my point here is a triangle is going to be half a rectangle. If you can see it visually, you can remember it. Triangles are half as far as area. And so what do I need? I need this measurement here, which I'm going to call B for base. And I need this measurement here, H for height. So just like the original, let me see if I can, like the original rectangle, the measurement, the 2 measurements are perpendicular to each other. That's what we're interested in. Some number across this way and some number this way, and the 2 are perpendicular to each other. So let's do a problem. Find the area of a triangle where the base is 12 inches and the height is 5 inches. So what do you think we need to do? We have to multiply the base times the height. And hopefully we remember that it's only going to represent half. So this is your formula, 1/2 times the base times the height. So if you, and I'll write all these formulas down for you, but the truth is you can see it from the picture. So in our case, the area of this triangle would be 1/2, and the base we said was 12 inches. And the height we said was 5 inches. Okay, I'm going to kind of write it sort of like a fraction. So the numbers is 1/2 times 12 times 5. And 1/2 of 12 is 6. If you want to do that like we've been doing with our fractions, and 6 times 5 is 30. So what happened, what's new about the triangle is this use of the 1/2 in the very front of the formula. We only have, a triangle is only half of what the rectangle might have been. So this then also is, I said inches, so it's square inches. If I draw it like this, I think it's even more obvious that it's half a rectangle. Isn't it?
Mm-hmm.
It's obvious. And so we know the formula is 1/2 times the base times the height. And so if this number was 4 meters, and this number was 10 meters, and let's say they told you that this number was a 12 or something, it may not be true. They may throw in extra numbers that don't count. The only number I need is this for the base, and this for the height. And who cares what this is? Nobody cares. The formula doesn't need it, and so don't be tricked into using a number that's not part of what's needed. So this would be 1/2. The base was 10 meters. The height in our case was 4 meters. So
You said 20?
Yeah. Area is, so I canceled 2 into 10 is 5. 5 times 4 is 20 square meters. If another thing you quickly in your head, because I made such nice numbers, 4 times 10 is 40, but we only need half, so it's 20. Are you ready for the circle?
Uh-oh.
We're going to find the area. And this formula you might have to write down, but I'm going to show you. I was at the Science Museum in Boston, which is a big fancy museum, and they showed a visual of how to see this. And so what I'm going to do is I'm going to draw a vertical line here. if you don't like this, but this is literally what happened. They had a circle and they had sand that was inside the circle, and it was possible to tip it. So you could tip this container so that you could fill the corners. And so literally, so let's just say this is the place where the sand's gonna fall into. And so if I took some of this sand and took it out and put it here, I would have a full square. And then the question is, using this as my extra sand, could I fill this corner? Well, I think I could. So I'm going to fill this corner. You see what I'm doing? I'm moving stuff from here to make a full perfect square. Do you think I have enough to fill this corner left over?
No.
There is, I have this much left. Yeah, I have enough.
Oh,
But what happens when I use this particular corner to fill in, to make perfect squares? I filled in 3 and I had a little bit left over. Guess what number that is? 3 with a little bit left over.
uh,
That's what I have. So I literally, I wanted to make squares because I don't know how to deal with circles. So I was moving stuff from, this was my extra place, and I could fill that one, and I could fill that corner, and I could fill that corner. I literally had 3 complete squares. Now this was a radius. And so if I look at just this, this is a square radius. And how many did I have if I use this as my place to like fill in the corners? I had this many, 3.14 of these squares. That's the formula. Now, whether you like that or not, I thought it was great. Area is pi r squared. The r squared is the square that's filled. The pi is 3.14. I could fill 3 of them. And I had a little bit of sand left over, not much, but a little bit. And that's your formula. So if you didn't like my discussion of the Science Museum, it doesn't matter. There's the formula. So let's say the radius is 5 inches. Okay. Your formula would be, instead of pi, they have you, this is an approximation, but this is pretty good. And so they say use that. And then it's 5 inches quantity squared. So if this was 5, the square would be 5 times 5. And 5 times 5 is 25, isn't it?
mhm.
And this, and then you just pull it out. And I'm pretty sure it's 78.5, but let me double check. 3.14 times 25. 3 times 25. 78.5. I use the same problem, so I know the answer. And then inches times inches is square inches. Partly because we have 2 of them here, and partly because area is always square. So we have an answer for that problem. How is that? So let's say they draw you a picture and they give you 10. and somebody says, well, let's have the area. You say area is pi times r squared. Then you say pi is 3.14, which they're going to give you. And then you put 10 meters and the square goes on the outside. Order of operation means that you have to do the squaring before you do the multiplying. It makes a difference. So 10 squared is 10 times 10, which is 100. So I did my 10 squared, it's 100. 3.14 times 100, when you multiply it by 100, the decimal moves over 2 places to the right. And so 1, 2, 314. And meter times meter would be square meter, but you only have to enter the number. How do you like it? You like it?
Mhm.
I like it. So if for some crazy reason they gave you this and the formula, somebody has their mic on. Oh, somebody needs. Okay. So this 7, the way I drew it, is what? Is it the radius?
That's the diameter.
It's the diameter. The diameter is 7, so the radius, and this is where we're going to need a calculator, would have to be half of it. So this is 3.5. So this is where we would pull out a calculator. So but let me show you. Area equals pi is 3.14. You've got to enter that number. You have to use the 3.5. You have to get the radius that's called for in the formula. So it'd have to be 3.5 quantity squared. So this is a case, if you ever saw a problem like that, well, you'd have to go 3.5 times 3.5. 12.25. Then you would have to multiply it by 3.14. And I don't think you want to do that by hand. So I'm getting 38.465. Okay, so see what happened. I did the squaring first, and I mean, you could do it by hand, but honestly, it would take a while. And then I got that number. And then I multiplied that answer by 3.14, and I got that number. Okay, so I just want you to be aware, and sometimes it won't be this annoying where the radius is some decimal like this, but it could happen. And so I just want you to be aware that it doesn't hurt to establish that what they gave you was the diameter. And what you needed for this particular formula was the radius. And so you've got to make sure you've got that squared away. You've got the proper formula and it's ready. And then you do it. Okay. So it is possible to find the area of a, so if you had a patio that was circular or something like that, and you need to figure out how much the area is, there's a formula to do it. Okay. And somebody figured it out for you, so that's pretty good. The last one, we skip one section, and this one is called volume. And what I want to do, mostly I'm interested in, let's see if we can. See. Okay. going to start with a square. And I'm going to turn it into a volume. So this is, I draw the two things identical. This is an art lesson. Okay. So the question is, what's the volume? So this is actually asking what's inside. So it could be like liquid that's inside or whatever. But what we need to figure out is what's the volume. And so it's a simple thing to figure out. So let's say this was a square originally. This was 3. And this was 3. So on the bottom, this bottom piece, it was 3 by 3. Right, which would have been 9. So just that part of it was 9. But then let's say it goes up 3. What do you think the formula is?
Base times width times height.
You've got it, except they'd probably use length, width, and height, but you've got, it's 3 times 3 times 3. So it's 3, 3, 3. The volume would be 9 times 3 is 27. And now, if this was all in inches, it's cubic. Inches cubed, inches to the 3rd power. We're in 3 dimensions, you see? There's a length and a width and a height. There's 3 dimensions to this. It's like a solid object. Okay?
The volume only comes if it's like a 3D object, like a box.
Yes. So volume will always be, the unit will always be cubed. Cubic feet, cubic yards, cubic inches, cubic meters.
Okay.
Okay. So, yeah. Now, let's say it was a rectangle to begin with. And now I'm going to turn it into 3 dimensions. Can you see it 3-dimensional, the way I drew it?
Mhm.
So the volume would be the length, the width, and the height. It's a pretty easy formula to use. So if the length was 6 and the width was 4 and the height was 2, just plain. It's the whole thing. And maybe they labeled them on the picture, or maybe they gave them to you like this, but this would be 24 to 48. And let's say it's all yards. How's that? So literally, visually, and so what I'm doing right this minute, people learn things on both sides of the brain. I'm on the right side of the brain right now because I'm trying to get you to see it visually. So it's basically the length times the width, and then how high did it go? That's the formula. So this part was just for the area of the bottom, length and width, which would have been 6 times 4. But then you had to know how high did it go, and it went up 2. And there's just one more. And I think this is a cylinder. Okay. We want the volume. Using the same thing we used for the last problem, you have to get the base. And so it's basically the area, the circle, multiplied by the height. So this circle is sort of like moving in up there. How high did it go? And so here's the formula. Area of a circle is pi times the radius squared. That gets you what I've shaded. Then you have to multiply it by the height. So let's say our radius, and I'll probably have to need a calculator, was 4 inches. And the height was 10. So this from here over was 4. This was 10. So this is using a formula. The pi we would put down as 3.14. The radius would be 4 inches quantity squared according to the formula. And the height would be 10 inches. So then at this point in time, I would just pull out the calculator. The only thing I need is 4 times 4 is 16, isn't it? So you've got to do the squaring first before you start to multiply. So it's 3.14 times 16 times 10. $3.14 times 16 times 10 looks like to me 502.4. Okay. Volume equals that. And there's 2 inches here and 1 inch here. And so that's inches cubed. You would only have to supply the answer. Okay. So this is pushing it a little bit going into that. But the truth is, if you see what happened, it was the area of the circle multiplied by how high it went. Okay. So, which formulas do we need to write down? Do we need the perimeter formulas? I'm going to make a list of formulas. So which ones did you need? Oh, that cute bunny, or whatever it is. What is that? Is it a cat? Which formulas did you need? Area. This is the shape. Can anybody recall what the formula was?
Let's, hold on.
Length?
Length times height. With
Yeah.
Yeah, and it's this measurement by that measurement. Okay. And so if you need that formula, fine. If you don't need it, fine. They don't do too much with this, but this was the parallelogram. They called it the base and the height. But it's really the same thing. The bottom by the vertical distance, which is perpendicular. Okay. And finally, the triangle. Anybody recall it?
half the base times height.
Yeah, half base times height. And if you, I mean, if it seems like it's swimming around too much and there's too much confusion, then make yourself a page. If need be, put the numbers in so you can see one example. And finally, in the category of area of a circle. Anybody recall it?
Half the radius,
This is
Okay.
area. So we're trying to fill it in.
pi
Here
times
times radius
squared.
square.
Correct. So this is the radius. And so that's what you need for area. Okay. Let's go back to perimeter. Perimeter actually was the easiest except for the circle. So I'm just going to make some shapes and you tell me perimeter. It's a square. Tell me
49.
how much?
Yes.
What did you say?
49.
Height times
49.
This is perimeter.
width.
We're going around,
Oh.
we're just counting, making a fence on it.
Oh. Height plus.
Positive
It's
sign.
24, right?
Mhm.
Almost.
7 plus.
Yeah,
Uh,
there's 4 of them. How much is
Yeah. 7, 14, 28.
28? Okay, this is our next one. 12, 5. Perimeter. So what I'm saying is in most cases, you don't need a formula if you just have a picture. But if you
34.
want to memorize a formula, the area was a little bit harder, but the perimeter, I think you can just look at the crazy thing. How much is
12. 12.
34.
5.
So we'd have,
34.
yeah, we'd have 2 12s and we'd have 2 5s. So this is 24 and this is 10. We're talking what, 34? It is, wouldn't it? If I'm still thinking clearly. Now, what about a triangle? Or what about a crazy parallelogram? Did it matter? We just took this and tipped it. So this is 12, this is 12. Let's just do the same numbers. What's the perimeter? I just took those things, and tipped it. It's the same, isn't it? I'd have 2 12s and 2 5s. It'd have to be the same, wouldn't it? What about the triangle? So we're still doing perimeter. I'm getting sloppy here. What do you do to get the perimeter of this?
We add all together.
That's it.
3,
That's all we're doing. 3 and 4 and 5. Okay. Now the circle. We're talking perimeter. I'm going to use a calculator, but you're going to tell me what I need to do. Circumference is the word they use, but it's really the outside edge. Does anybody recall it? Pi, pi,
plus times This.
the diameter.
Okay.
So what is this 6? What's the word for that?
Radius.
It's a radius. So the radius is from the center out. So this is what we're maybe not used to this, from the center out. The radius is 6. What's the diameter going all the way across?
12.
12. So the formula, once we've established that, the formula would be, what did I do? 3.14
And 14.
times 12. And I'm just gonna take advantage of the calculator that's in my face. 37.68. Remember wrapping it around, it wrapped around 3 times. It was the diameter that we wrapped.
How about the 6? You didn't add the 6?
Remember, the 6 is just the radius and the
The
formula
half.
is the diameter. So the diameter would have to be 12. So we have to be able to distinguish between radius and diameter. Now, you may have seen, maybe not this word radius, but diameter. You see it like dishes. They talk about the diameter. So if it's a dinner plate, it's maybe 12 inches across or 10 inches. If it's like a little plate, like for dessert, it might be 6 or 7 inches. And they talk about the diameter. So you would see that in the description. So you'd get the right size if you wanted to order something. Right. Okay. And then there was the volume, and I'd probably just do this one. What's the formula?
3
Length times width times height.
times.
Times height. And I probably wouldn't do the cylinder on, I wouldn't test it, but I gave you the formula for cylinder, so you could do it like for your homework. But this one, I think that's the length, that's the width, that's the height. Multiply the 3 and you're good to go. Okay. So, let's see, what I want to do quickly. Let's see, I want to, I don't want that, I want this. Can you see the XYZ?
Yes.
Okay.
Yeah.
I just want to show you where we are. Here's today, the last day of November. And so these 3 sections, perimeter, area, volume, these 3 are due Friday. And so we're done with chapter 8. And so you just want to get that done. And then next week we'll do chapter 11. There's 4 sections. After that, we'll definitely have a class on December 12th. The final is actually scheduled on a Thursday morning. And so the Seattle College actually sets the final schedules. So this allows for a little bit longer test. And so 8 to 10. So that's where it is at the moment. So that you don't, that it's set so you don't have conflicts with another class. So that's the way it is there. If somebody has managed to skip some of the homework and they want to actually do it and get some more credit, then you need to send me an email very soon, not the last week. The last week is so busy, we can't be fixing things at the last second. So we need to do this now, this week or early next week. Send me a message and ask me to open up a couple of sections and tell me specifically what sections you missed. So if you didn't do a section, I can open it up for 2 days and maybe you can get a little more credit on your homework. And so that's what I want to do. All these issues need to be solved immediately or right away this week if possible. So then you can, or you could ask me, you know, could you open it up on Friday because I have the weekend off? And then I'd give you 2 days, sort of like an extension. And then you can get some credit for something you might have missed for whatever reason. Any question about that? So I will open up.
I have one.
Yeah, go ahead.
I work on Thursdays, and I don't think I'd be able to get out of work for the test. Is there a way I can do it on a Wednesday?
This is an interesting thing. Technically, I have to offer at that time. We could do it on the Wednesday, but it could be a conflict for somebody. Does anybody seen their, most people have 2 or 3 classes at the moment, right?
Yeah.
Yeah.
Yes.
And so the real question is, do you have a conflict? Because we could move this.
I personally also have, I actually have a class that starts at 9 a.m. on Thursdays. So, I mean, I could probably,
Or there won't be a class because this is finals. These last couple of days are finals.
oh, sorry, I meant an
It
English
would be a-
class.
I don't think there'd be a class.
No, no.
Oh, I see.
Yeah, she's saying like all classes.
All classes. Gotcha. Okay.
And so, but it is an option for us to consider having the final on the 14th, on the Wednesday. And maybe we would put it, you know, so that we finished in the morning, kind of like a normal day. Maybe
Yeah.
to 11 or something like that, so that we had a full 2 hours.
Yeah.
I have a conflict with, I can't do it on that Wednesday. I
Yeah,
have a
but I
doctor
mean-
appointment during that time period that took me 6 months to get.
Yeah, so what, I'll have to figure that out. I may have to offer it both days. I'll have to see. I think if this is the official day, the Thursday. And so if anybody has a conflict with this Thursday, send me a message so I know how many people there are. Okay? And then I'll figure out what to do. So we have conflicts if there was no clear choice between these two. So somebody's going to be, we're going to have to make an exception for somebody. So we will make an exception so that everybody gets to take the final, because you need to take it. It's worth more than the other tests. But we need to make sure everybody takes it. So if you have a conflict either Thursday or Wednesday, send me a message and I'll see what we can do. Okay?
Is it
But I
on,
wanted to talk about it now so that we can be a plan, have a good plan.
is it on XYZ or is it at the campus?
It's on XYZ,
Okay.
but it'll have a password, so you'll have to come to Zoom.
For
Got it.
the classes on the 12th and the 14th, are we going to use those as review days?
Well, definitely the 12th will be review.
Okay.
And so it just depends on what we decide about this. All of the 12th will be review. And the question is when are we gonna, if the official day for the final is Thursday, we could have another review.
On the 14th.
I almost have an idea, if I had a clear idea of how many people had issues with the timing, okay? So send me a
Okay.
message and I can figure it out. but we may make this Thursday the official day, and then it might be possible to help other people that can't do it. Because it sounded to me like at least two people that are here had trouble. Okay, so we'll have a plan, but we want to know ahead of time so that everybody is lined up correctly. Okay, is that clear? Clear,
Yes.
Bud. Right.
Yes.
Okay, let's call it. Okay, so I'm gonna stop recording.